Hello everyone, I would like to welcome you. First of all, I would like to thank Science on Stage Europe for this opportunity which brought us together. Today I am today I'm going to give a presentation about BBC Microbit. My name is Selçuk Yusuf Arslan. I am a computer science teacher in Ankara, capital of Turkey. I'm also a PhD student at Educational Leadership Program at Hacettepe University. I'm one of the Microsoft certified educators, and I'm responsible for some global projects such as 100 Teach SDGs and Scientix as an ambassador. I focus on coding, especially for girls, STEM education, and sustainable development goals. As you see, my presentation is divided into 5 parts. Firstly, I will introduce Microbit. Following that, we will continue with Microsoft Makecode basics and Microbit's integrated sensors. Then, 2 different opportunities for teachers, Do Your Bit Challenge and European Code League. My presentation will take about 40-45 minutes, and finally you can ask your questions during QA sessions, but feel free to interrupt if you have any questions. I will try to look at chat box. So let's start with Microbit. The Microbit Educational Foundation is United Kingdom based non-profit organization. It was first announced on the launch of BBC Make It Digital campaign in 2015 with the intent of delivering 1 million Microbit devices to pupils in United Kingdom. This tiny pocket-sized computer encourages kids to learn basic coding and programming skills to prepare them to feature. And Microbit's vision is to inspire every child to create their best digital feature. Okay, so let's move on to features of Microbit. The Microbit LED screen has 25 LED lights arranged in a 5 and 5 grid. It has a light sensor and the Microbit has 2 buttons, button A and button B. You can see input-output pins and edge connectors on the bottom, and it has also external power supply. When your BBC Microbit is connected to your computer with the micro USB, it doesn't need another power source. The Microbit can also be powered using 2 alkaline batteries. You can see the reset button on the top. It uses Nordic main processor. Additionally, it includes integrated sensors such as Bluetooth magnetometer or accelerometer. And last Tuesday, Microbit announced the new Microbit. They integrated microphone, speaker, and a touch sensor to the new Microbit version 2, and it will be available as of November 2020. In order to program Microbit, we can use different tools such as Microsoft Makecode, JavaScript, Python, and Scratch. I will continue with Microsoft Makecode because Makecode is useful for beginners. We can use Makecode in 2 different ways. Firstly, we can visit makecode.com and use it online. Secondly, we can download Windows 10 application through this link. There are 3 advantages to install Windows on app. First, we can use it offline. Second, we can download our programs easily. And third, we can use data features with application. When we open the Makecode, this interface welcomes us, and we can continue to click New Project button. Now we have come to main interface. On the left side, you can see the simulator. After the presentation, you can try the applications I show, even if you don't have Microbit. On the right side, you can see the workspace. On the bottom, you can see undo, redo, zoom, save and download button, which we use for downloading our applications. On the top, you can see homepage and share section, and also blocks and JavaScript tabs. We will use block-based programming. And finally, on the center, you see the toolbox, which includes the categories such as basic, input, music, LED, etc. In order to download our program, we use download button. After that, click right mouse button and transfer a hex file, which is downloads folder to the Microbit. And now let's move on to Makecode and try. When we open Makecode, you can see on start and forever blocks. As you understand from the block name, on start block runs when you start the program. In other words, it will run once. On the other hand, forever block keeps running until you interrupt the program. Now click on the basic category and drag the show string block over and place it on start block. Now we can see the output in the simulator on the left side without installing the Microbit, as you see. And second, and you might be wondering how you will delete, for example, this forever block. It is very easy. You can click the right mouse button and select delete block, or you can drag it to the categories toolbox and you can delete it. And now we will change the string or our message. I will type here another message, for example, Science on Stage Europe. And let's look at the output from the simulator on the left side. If you want to type a number, you can use show number block, and also this block is in basic category. Or you can use search area. For example, I will type show, and the results are here. Search is a powerful tool, and we place show number block inside the on start block, and we can change it, and we can see the output from the simulator left side. So let's move on to LEDs. You can find show LEDs on the basic category. The process is similar to the others. I drag and drop the block inside the on start block. Now I'm creating a basic image. And that shows up in the simulator on the left. If I change my design, it will be updated in the simulator, as you see. I will delete again. And we can also get the LEDs ready. We can find show icon block and drag it inside the on start block. You can see different images such as heart, yes, no, happy, t-shirt, etc. For example, I change and we can see the output on the simulator. Now I delete all the blocks now, and let's move on to buttons. We use input category for buttons. My aim is to show yes images when I click button A, no image when I click button B, and a happy smile when I use button A and B together. So I added I added on button A pressed on the workspace, and I drag show icon and I choose yes. Now let's move on to button B. We can use two different ways. Firstly, we can add on button A and change the name of the button as B. And secondly, we can click right mouse button and duplicate it. And after that, we can change the button's name. Also, we can change the icon, and I choose no. And you can use whatever you want. They are same. And the last, I duplicate again, and I choose A plus B, and I change the icon, for example, this one. And now let's try. We must click the buttons. For example, I click button A and we see the icon, yes icon. When I click button B, we can see the no button. And here is a different thing. Here is a third button. If we click button A and button B at the same time, we can use it as a third button, and we use the happy smile. Basically, button usage is like that. Let's move on to sensors. I will show an example with temperature sensor. Also, I will show if-else block. As I mentioned on my presentation, Microbit has some integrated sensors such as temperature compass, Bluetooth light, etc. Now I will use forever block. It's here. Because I want my program runs continuously, I drag and drop an if-else block from logic category. I place it inside forever block. And if the temperature is less than 5 centigrade degree, show a message like too cold. Otherwise, show a message like not bad. Let me show how I code. Here is comparison tools, and I change it. Also, on input category, I can find temperature, and I drag and drop it here. If temperature minus or equal 5 degree, show a message too cold. Otherwise, the message is not bad. Yes, now when we look at the simulator, we see not bad because the simulator set up 21 centigrade degree. Because of that, it is not bad. For example, I change it, for example, 25. And the output also changes, and it is now too cold. You can use it your lessons with your students. It's a good feature, I think. And let's move on with another example. This example is that when I click button A, I will increase the number one by one. On the other hand, when I click button B, I will decrease the numbers. Let me show. Firstly, I create a variable from variable categories, which is red. I want you to pay attention. The colors of the categories make it easier to find something. The name of the variable is count. Yes, I created it, and I use button A again, and I use on start. Sorry. On start, I will set the number to 0, and I must show the numbers. But which number? My number is represented with count, and because of that, on the variables category, I must drag and drop count inside numbers, and now we can see the output. On button A pressed, change count by 1, and it means increase the number 1 by 1, and show numbers, and the number is count. Now I'm trying on the simulator. When I click button A, it is increasing. And now I will add button B, and change count by 1, but now I have to change it -1 instead of 1. It means it will decrease 1 by 1, and also I will add show numbers, and this numbers represents count. And lastly, I can add another button, but before I will try. Now it is increasing, and now it is decreasing. I will add another button, and it must be A plus B, and I duplicate this code, set count to 0, and it is enough. For example, now I'm increasing, I'm decreasing the number, and when I use A and B button, sorry, I must add it, it will be 0 again. Yes. Now when I use it, I see 0 again. And we can use a random class while we are coding. And I will show another feature. Now, when I shake Microbit, a random number will appear on the screen. I use onShake block. OnShake is here. And also, I will use numbers. And because of that, I drag and drop and show number block inside the onShake block. And we can find random features on math category. Here, pick random from 0 to 10. And now I'm determining a number range from 0 to 7. And I will turn my camera, and I want to show it with a real Microbit. I download the program, but before I download the program, and you can find it on downloads folders. I'm opening. And there's a hex file. I click right mouse button and send it to Microbit. It's like a flash disk. And I'm sending. Now I think you see my camera, and now I shake it. For example, it's 4. I shake 0. I shake 1. 4, 2, 0. It is like this, and it is a Microbit. It is really very small, and it has user-friendly interface. Let me share my screen again. I create a variable as the name of step, and after that, now I set the beginning value as 0 on a start block. I use forever because I want to count my steps continuously. I have to show my step numbers, and I use Wait a moment. Forever. I must show my step number. And sorry, it's step. And I use pause block to refresh the step number. And the main part of the program is on shake. I use change step by 1 to count. And every shake means to increase step number 1 by 1. Yes, it finished. Let's try it with simulator. By the way, when I click shake, I have some opportunities, such as logo up, logo down, screen up, screen down, and you can see here G forces, which the physics teachers can use during their lessons. Now I'm trying. When I click on shake, it is increasing. For every shake means to increase step numbers 1 by 1, like this. And the final example. I designed a simple tilt alarm with on shake. Let me show code. I will use an icon, and because of it's a tilt alarm, I can use angry smile. And on music category, I use play melody. Where is it? Oh, sorry, start melody. I can set once or forever from here. Once is enough, and here is the melodies, for example, funk. You can use it with your bags. When someone touches your bag, now I'm trying on the simulator, anger face, and after that you can ring a melody like that. You can find some examples on Microbit website, and now let me move on with my presentation. And the Orbit Challenge is an international competition organized by Microbit. The goal of this competition is contribute the sustainable development goals. Microbit will share the contents prepared for this contest on its website on December 1st. And students aged between 8 and 15 can participate in the contest. And the deadline is 4th June next year. For detailed information about the competition, you can visit the Microbit website. And thank you for your attention. I'm open to answer your questions. We have some different projects. 2 years ago, I conducted a project called More Coding, More Girls, which was granted by Science on Stage Europe. Students made some projects with microbits, such as alarm systems, home security systems, simple robot cars, etc. And we organized an exhibition, and they gave information about their microbit projects to the attendees. And this project was awarded by STEM Alliance 2 years ago. And also I gave a presentation on Microbit live in Manchester last year. And also I gave a presentation on BET this year in London. I think we can do a lot of things, and our creativity is very important, I can say. There's a question from Özlem teacher. Can we buy the real VVC Microbit on internet? Yes, you can. For example, in Turkey, you can use Robotistan, Robolink, some equipment, some robotic equipment websites, and it is also 15 euros. For example, in the early age students, I use Microbit because it is very simple, and for beginners, it is very beneficial. We use it, for example, last days we use it for European Code Week. And I will continue because when I compare it with other tools, it has a lot of advantage. It has become popular. Integrated sensors are really very amazing opportunity because some students can experience some difficulties. They use the sensors, but for Microbit, it is very simple. Some big organizations support Microbit, such as Microsoft, and because of that, we can code it easily with block-based programming, or we can use Python or MicroPython when we code it, and it is really very easy. Thank you to you and Science on Stage for this opportunity. It was a pleasure for me, and have a lovely day, all participants, and to you.